On the TNE segment, I have here with me David. Hello, David.
Hello, Aurelia. How are you?
I'm fine. What about you?
I'm doing great myself.
Please introduce yourself to us.
Okay, my name is David Abrampa, and yes, I'm a student from Maker's Place. I've been coding for 2 years now. Yeah.
Oh, okay. What are we going to be doing today?
Okay, so I'm going to teach you how to make an automatic irrigation system using the BBC microbit.
Please, let's start.
Okay, so I'm just going to go through some of the materials you'll be needing to make an automatic irrigation system. You need crocodile clips or alligator clips, a battery, of course a BBC microbit, and a sensor. The sensor is what will check the moisture level of the soil to tell us that if we are going to add some water to it, if it's dry, or leave it as it is if it's moist. Yeah. So I'm just going to assemble them right now.
David, what is the objective of this project?
It is to make it easier to irrigate crops, either small scale or large scale, in your garden or on a farmland.
Is it necessary for you to have these colors?
No, the colors don't really matter. They are just to for you to be able to differentiate between which pin or which ground you're using.
How did you end up being a student of the Maker's Place School?
So it was during vacation, and my mom was going through her status. She already knew I was very interested in coding, and she saw an advert of Maker's Place, and she decided to make me join. And it's been very interesting since then.
So what are you trying to do right now?
Okay, so we have 2 microbits over here, and I'm going to make them interact with each other so that this one will pump some water into this bowl right here. So right now I'm just connecting the wires to it so that it will give it power.
So which industry can this be useful in?
Well, mainly the agricultural industry, but that's not all. It can also be used in your home, as I said earlier. You know, you always have a hassle of maybe getting up in the morning and go and irrigate your crops yourself. This is an easier way to do it, since it reduces the human stress of waking up every morning or 2 days to go and water your crops manually.
I can see right now you're trying to connect the wires to the sensor.
Yes. The sensors also have specific areas where they are linked to the microbits. So when the sensor is inside the soil, how the rate at which they can interact with each other is sent through these wires and the microbit sends the signal to its power over here to pump water.
So what do we have in here?
In here is just water.
But I can see something here.
Yes, that is a device used to pump water. So it obeys the instruction you give to it. So if I say that, if I code it into it, that it should pump water into this for a specific number of period, a specific number of time, it does so.
to, I would say, command the device and it to pump water into this one?
There are lots of applications that can be used to make instructions, but for the BBC microbits, we use a website called makecode.org. Yeah, it looks like this. So we use block code to upload a code onto the microbit.
Oh, okay.
So right now, the pins are connected to some holes in this microbit. We have the pin 0, the 3 volts, and the ground. We also have those labels on the sensor. So every cable must be connected to the corresponding.
You don't have to mix it up.
Yes, or else it won't work, because ground is to ground and the volt should also be to volt. So this is the ground cable. It's connected. I use the green alligator clip.
You made mention earlier in your introduction that you started all this 2 years ago. So how old are you right now?
I'm 14.
14.
Yes.
So you were 12 when you started?
Yes. It was during the COVID-19 era. Yeah. Okay, so now I've successfully connected the wires from the microbits to the sensor. Now all I need to do is to connect this battery to the microbit to give it power. Oops.
Oh, so you have to turn it on.
Yes. This is actually a container for the battery, so you can turn it on and off to determine when you want to give it power or not. So right now, if you take a look at the microbits, you see one LED on. In the code, we made it in the way that if only one LED is showing, it means that your soil is very dry. So when you see just one LED and you want to check how much dry or moist your soil is, you click on the button A and it shows the number. So right now, when I hit the button, it was communicating to this microbit that it's less than a particular number. If the moist level of the soil is less than 900, it means that the soil is very dry and needs to be irrigated. But if it's more than 900, it means it's wet and doesn't really need. Right. So as you can see, it's released some amount of water inside because the soil is very dry.
So you instructed it to?
Yes. There's a code for this one and there's a code for this one. Although we use the same website, but they are communicating using radios. The microbits have tiny sensors that they can use to communicate with each other. So whenever I click on this one, it sends the number.
Instruction.
If you take a look at the LED, you see a specific number. It sends that number to this microbit, and it checks if it's less than 900, then it pours water into the microbit.
Wow.
Yes. So that's it for automatic irrigation, irrigation systems using the microbit.
Wow. This is so amazing. and I would say it makes work easier
Yes,
and
very.
also faster. Thank you so much for your time,
You're welcome.
and I hope my viewers watching have learned a thing or two about this.
This is us.